Right, so having sent those radios back to Leeds, we've got another one. I recall this being a Midland Port-A-Pak. I don't think Mr. Chippy's opened this package quite enough. It's a difficult one, because we don't want to open packages until we're ready to do them, and conversely I want people to know that I've got the set safely, so we kind of have to have a peep. I think it's something about not having any audio through the microphone, because it's a speaker microphone on these. So we'll get our little power lead. So he's put his name on that, but I don't want to show that because I don't want him to get people calling at his door wanting to borrow his CB. Right, we'll connect it up to power. I'll run this at 12.8 volts, with it being a 12 volt set. We've got some 24 volt droppers to do, and so I'm going to pull that in with a video about the kind of power supply we use on the bench here. So it comes on, it's on channel 24. We'll plug it into the test equipment. Plug the mic in. Turn the squelch down. Nothing through the mic. Transmit's working. Wallow. 1 2 1 2. Were we on a different band last time? 1 2 1 2 1 2 1 2 1 2 1 2 1 2. Well, it doesn't actually have any transmitted audio either. So if we just put our monitor set on, testing 1 2, testing 1 2, 1 2 1 2. So there you go. So we'll plug in an external speaker. Right. Well, there's a bit of proof, isn't it? I'll get a piece of paper and we'll write down what's working. Oh, Christmas calendar. From what we were, had to take my flipping electronic keyboard to various pubs around Christmas and do Christmas carols. Right, so it's the Midland 77805, isn't it? $77,805 UK, so it's not the D version. I've not noticed any performance difference between the two, even though some people say the D is deafer. Right, so let's look at what it's doing. So I'm on the 3 watt scale, and that's doing 1.8 watts. Just make sure it's not in the wrong position for power. It is. So it's doing 5 watts, so that's going to have to alter. It's doing... It's so off frequency, it's beyond... I'll show you that. So it should be 2779125, and it's 058. Anything under 085 is unacceptable, it's out of spec. So this is going to be performing very poorly because of that. So we've got a no deviation. On receive, and I'll tune the receiver to match it's being off frequency so it's fair. Obviously if I test the receiver spot on frequency, it's not going to perform as well because the radio is off frequency. So I want the signal generator to be 79059, somewhere near there. We're on the fine tuning now. So we've now got the receive matching the transmit. Let's see what it's doing. Put the cyanide meter on. We'll just flick across to there. Why aren't we getting anything? There we are. So for 12 decibels, where's my pen gone? It's doing, oh that's alright. So it's 0.52 microvolts for 12 dB cyanide, which is going to be probably exactly where it ought to be. So our biggest thing with this is there's no receive coming through here, through the mic, and there's no transmit coming out of the mic. So let's hope the microphone or speaker isn't open circuit, or let's hope the transformer isn't, best word for that is knackered. So we'll open it up. You know, all the time I've been showing you this, I've not had picture in picture on. So you'll have to take my word for it that it's got no deviation, and it's 2779059, and that for some bizarre reason it's doing 5 watts. Once again, we don't do mic repair, so here I am doing a mic. So before I have to dig the circuit diagram out, we'll see whether there's anything absolutely obvious. It's clearly had some work gone in here. I'm going to put our little monitor receiver on for a silly little test. One of those silly little tests that saves a lot of time. I'll stick my finger on it. So as you can hear, it's actually transmitting . So in here, there should be a matching transformer. I've never seen one wrapped up before. You know what? I think there's a break in the mic lead, or a wire off at the mic plug. So key it up and then fiddle with the lead. It's as if the earth's off, folks. We've got a jumper lead. We're always pinching them off Mr. Chippy's bench, so we ought to have. No, I think I'm going to have to go and pinch another one. My plan is to jump the earth from the mic to the chassis of the radio and see whether that brings back normal function. So it looks to me, when I jumped it across, we got some operation, and it looks to me like this wire here, which goes to the speaker chassis, goes to the transformer, goes to the speaker. It looks to me like that's open circuit. So I just think it's a matter of a bit of bad soldering. It's been looked at some time in its career. Of course, now these are at least 25 years old, and this version's probably 35 years old. I have to look for the date code, won't I? What I want to do is to unsolder that green wire. It's because it might be that the insulation is damaged. Put the soldering iron on ready. I'm just going to switch the set off a moment. This is the one with the real channel selector switch and not a glorified up-down, which you get on the D version. That's my only dislike of the D version. Right, let's remove that. So we can hopefully dress that white wire differently. So I just felt it was a bit tight, and there was a possibility it could cause the insulation to migrate on the white wire. So when you actually look at this, I'll just zoom in. So that should be soldered to the speaker, goes to the chassis. That's to stop it making clicking sounds when you're touching it. So this is why you ought to be making a, not just soldering on top of something, but to actually make a proper mechanical joint, not just soldering to something. I just hope the speaker's not damaged. Let's see whether we can do that. Well, that's certainly gone into position. So now we'll solder this green wire. Just going to re-tin that. And there's a bit much of it. Cut the end off. And then solder that onto there. Just like that. Switch back on. See what happens on transmit. 1 2, testing 1 2. Okay. So we'll have to wrap that back up. I've cleaned the switch at the same time. I did that first just in case it was something as stupid as a switch. We'll just turn this back off again. They're like gold dust, these mics, aren't they? Let's put the camera back to where it should be. You often see them changing hands at £35 on eBay. I bought one for £16.50 as a non-worker, but I was able to fix it. And it had been rewired really stupidly. There we go. Right. So we're back in the land of the living with the microphone, so we'll go through the set now and see whether we can get it on frequency and transmitting. I'm going to put the spectrum analyzer on because with it doing 5 watts, I'm intrigued to see how much of it is on 27 megs. Whether we're talking to aircraft band or something on it. Oh yeah, they turn the power up, but then all the other things are wrong, so it defeats the object. I'm going to have to look for a service manual for this because it's a few weeks since I've seen one and I've got a memory like a sieve, as everybody knows. What I can do is to put it on frequency. We'll do that right now. So we'll put that onto the... There we go. So we're looking for 27.79125. There's a trimmer there. Hopefully it will go. I'm going to turn it round a few times because I think it's a bit dirty. So we'll have it slightly high as I usually do so that it's got a bit of room to drop. They drop naturally with age. Quartz crystals do that. So we've got it back on frequency. So I'm looking at capacitors. Everything looks fine. Good. Well, the first manual that came to hand was the Midland 77104, and this version of the 77104 is pretty similar, so we'll use that unless I come unstuck. Save me going through filing cabinets, etc. So we'll just look at the spectrum analyzer first. Let's have a look. So we've got, right in the centre, we've got 54 megs, so double 27. We've actually got nothing whatsoever. So the fact it's doing 4.9 watts hasn't really caused any issues with that. So let's see what we've got to adjust. What we will, first of all, I'll just look at the low power situation, because it should be 400 milliwatts. So on low power, at the moment we've got 1.8 watts. So it wants to be 400 milliwatts, which is there. It's that coil that seems to have been disturbed. Still look at the spectrum analyzer. So what I'm going to do, we'll peak it all. So full power, that's full power. Well, that was out. That's fine. There we have it at 4 watts. So we'll just go and check low power again. That's 400 milliwatts. Switch to high power. That's 4 watts. Well, it's 4.05. It'll soon drop down. I'm just checking back on the spectrum analyzer. Key up. We've got nothing, which is what we want. Just make sure the fundamentals there. Do with the. Yep, that's fine. Switch that off. I just wanted it to be one of these sets where you have more on another band than you've actually got on 27, with it being fiddled with at some point in its life. So now we've done that, we can set the S meter, the RF meter. So you do this on low power, and it should be 1 bar, and it is 1 bar on low power. So I don't need to adjust that. It's 4 on the 4 watt setting. So it's set in the low power mode to 1, and it's going to be the right hand preset there. Deviation. Put the oscilloscope on. Wallow, 1 2 1 2, wallow. It's a bit low. Am I doing the wrong one? Yes, I am. Wallow, that's too high. Wallow, 1 2 1 2. That's it. Spot on. 2.2 to 2.5. Put the monitor receiver on. Testing 1 2, testing 1 2, testing 1 2. Wallow. Good. So that brings us to receive. So I'll plug in the external test instruments into the speaker socket. Let's see where we are on that again. Measuring it this time, it's 0.56 with the lids off. Right, so we'll set the attenuator so that we've got about 4 dB on the sound meter. You know what, doing this in the wrong order, I'm ahead of myself. I need to put an S9 signal on and look at it on the oscilloscope and make sure we're setting the detector miles out. Bet they sounded like Daleks. Now we'll go to the sound meter. Get about 4 dB on there. Very slight improvement there. Considerable improvement there. Turn the attenuator down. No improvement there. No improvement there. So I'll just go back to the first two. No improvement there. No improvement there. Right, we'll read off what we're doing now. So now for 12 decibel cyanide, it's doing 0.52, which is exactly what it was doing before with the lids off, on. But there is a slight difference, and the clarity is going to be better. See what it's doing for 20 dB. For 20 dB, we can achieve that with 1.3 microvolts, and for 10 dB it's 0.44. I've just realised something. I've still got this signal generator off frequency, haven't I? Ha 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 ha. I've still got the signal generator at 79059. So I'll just put the signal generator right. So we set it to 79128. I'll just check on transmit. 2779126, toggling 7, back to the receive. That's where we are. So we've now got the two matching. So I'm going to recheck the detector. So I might have set it lopsided. No, it's absolutely spot on. Just check these front end ones again. Just in case I got it lopsided. Right, now we'll read that off again. So 12 dB on the cyanide meter, and it's 0.5. Before we put the lid on. Just see whether the lid affects it, because it certainly affected it initially. Yeah, it's now 0.495. It does make a tiny difference. So we need to set the S meter. With an S9 signal on the radio, it should read S9, which it does. Advancing the signal generator should bring it to plus 30, and decreasing it should bring it down. So it doesn't need adjustment. It's not often I see this where they don't need adjustment. It would be that preset if it does. Now the squelch. So we're going to put the squelch to full, and we want 100 microvolts on the signal generator. Now, if you remember, I've turned the wrong preset, so I've upset this. I don't know where it was. So we need the squelch to come in at 100 microvolts, which it doesn't actually want to do. So we'll go up a peg. Where am I going wrong? So on this version it doesn't want to open at S9. It's actually, the minimum it will open at is 4.9. So I wanted 100 microvolts maximum. It's actually 150, 160 microvolts. That's the minimum you can set it to. So, okay, it doesn't want to play ball. We'll turn the squelch down, check it at the other end. So once again, we'll set the signal generator, park it to 0.3 of a microvolt, and we'll set the squelch to threshold. So going back to the maximum squelch, which I'd like to be 100 microvolts, in this case it's 160 microvolts, at least it does open, because there are some radios that are maximum squelch, it never ever opens, even if you're transmitting a foot away, and that's absolutely pointless. So at least it does open, but it's not how I like it personally. So let's switch the signal generator back on, and it's come straight in. So we've got a squelch sensitivity. It's coming in at just 0.32 of a microvolt. It's staying in until 0.12 of a microvolt. So it's very sensitive squelch. No arguing at all. Okay, so there we have it. So we've sorted that out. So that's 4 watts and 0.4 watts as it should be. 79127, deviation 2.2 to 2.5 and 0.50 microvolts. So that's gone through it nicely. So we'll disconnect the external speaker, we're on the internal speaker. We'll put the lid on. There's a chance Mr. Chippy will test this with us tonight. We do these tests at 7:30 in the evening. I know there's been some requests for a bit of dash cam footage from Mr. Chippy's side, but until the evenings are a bit lighter, you know, we're halfway through March, there'll be nothing to see. There we go. So now we will put it on the aerial and turn off the test equipment. So once again, it's an Antron 99 type of aerial without the optional ground plane kit, mounted just above the gutter of a single-storey building. One on a Roger. This is something on 30. No, nobody's swearing on 19. Right, there we are. So that is the Midland 77805 UK from round about 1987, 1989. It's the earlier version than the D version, which is not loved as much by people. So needed a good service, miles off frequency, but the receiver was good, and it's even a little bit better now. But the basic problem was bad soldering, which had come away inside the speaker mic. So thanks for watching.